Welcome to my Kcse Mathematics Revision channel. Teacher Marita. Kindly subscribe my channel, watch and share. Today we are looking at past cases questions on longitude and latitude. So I have a question here of 10 marks as the position of three poles A, P and C. We have been given three poles there. A is at 34 degrees north. So we have 34 degrees north, 16 degrees west. Then we have what P is 34 degrees north. Then we have 24 degrees east. You will notice that these two poles A and P, they share a common latitude of 34 degrees north. And that is what you can see. Then we have C, which is 26 degrees south. Then we have 16 degrees west. You can also notice that A and C, they share a common longitude of 16 degrees west. So the distance between A and P is the distance along the small circle. The distance between A and C is the distance along the great circle. Understand? So we are supposed to find the distance in nautical miles between poles A and P. So what is it? So A and P, these poles A and P, it is the distance along the small circle. So there is this latitude of 34 degrees north. So this is our latitude of 34 degrees north. In this latitude of 34 degrees north, there is 0 here, which is of course the equator. Then we have from 0 to A, we have 16 degrees west. So this is where we have our point A. Then we have from 0 degrees, which is our green meridian, 0 degrees. Then a ship moved to port P, which is at 24 degrees east. So the angle between A and P is 16 degrees plus 24. So that one will give us theta, which equals to be 16 plus 24, and that one will give us 40 degrees. The distance between A and P is the distance along the small circle in nautical miles, which is given as 60 times theta, where theta is the angle between the angle subtended between A and P. Then we have cos alpha. Cos alpha is the angle of that common latitude of 34 degrees north. So in this case, our cos alpha is the same as cos 34 degrees. So to get that distance now is, distance is 60 times 40. 40 is the angle subtended between A and P. Then we have cos 34, a common latitude, and that one will give us a distance of 1990 roughly nautical miles. Then we have a distance between A and C. A distance between A and C is the distance along the longitude from north to south or south to north. That distance in nautical miles is just given by theta, 60 multiplied by theta. So, but what is our theta in that case? So this is our that longitude of 16 degrees east. So we have equator here. From the equator here, which is 0 degrees, there is 0 degrees to 34 degrees north, you have point A. 0 degrees from the equator, 26 degrees south, you have point C. So this is the distance along the great circle. So the angle between here, it is 34 degrees north, 34 degrees north plus 26 degrees north, and that one will get us 60 degrees. The distance is 60 times theta, which is 60. Our theta is 60, so that one will give us 3,600 nautical miles. A ship left port A on Monday at 13 hours. So it left at this point at 13 hours and sailed to P at 40 knots. So there are two things here. There is this distance there is this speed in knots, then we should have our distance. Then we should have our distance. Our distance as nautical miles, which is 1990. So Roman A, we are supposed to calculate the local time at port P when the ship left A. The local time here at this point when the local time at this point P when the ship left at A. So what did we do here? We have the latitude different, longitude different. The longitude different between A and P. It is A and P, which is 16 plus 24, and that one is giving us 40 degrees. That is our longitude difference. So we know that 1 degree is equal to before minutes. What about this 4 degrees, which is equal to before times 40, and this one is giving us 160 minutes. 160 minutes can be converted to hours, and that one will give us 2 hours 40 minutes. So this is the same as now here, 2 hours, then we have 40 minutes. Then we need the time at P. So time at P, So if our ship left here at 13:30, so it is 13 hours. And then this point P is east of A. So the boat at P, the time at P must be ahead the time at A. So we are expecting the time here to be ahead of this one. So what did you do? You take 30 hours plus now 2 hours, 30 minutes. So you 2 hours, and then we have 26 minutes. So this one, if you add that one, now, you will get in that case 30 plus 2 hours and 40 minutes is 40 minutes here. So we will add 40 minutes here. That one will give us 10 hours. So the time at P is 10 hours. We calculated the time taken from A to P. So we know that time is equal to the distance over speed. The distance is this one, so we have this is 1990. We have our distance, which is 40 knots. So you divide this one by 40 knots, and that the distance at the time will give us 49 hours, 45 minutes. So we have this is 49 hours. Then we have 45 minutes. Then from there, we need to get the time from A, the day and the time the ship arrived at P. So time taken from, this is the time taken from A to P. Time taken from A to P is 49 hours, 45 minutes. So it is a journey of 2 days. So after 2 days, how many hours remains from here? So after 2 days, after a journey of 2 days, we have this is 49 hours, 45 minutes, then minus 48 hours. So there is a difference of 1 hour. And then we have 45 minutes. So the day and the time the ship arrived at P is on Wednesday. So the day Wednesday, the day arrived because it started on Monday. So it left here on Monday, Tuesday, Wednesday. So it arrived on Wednesday. Wednesday at what time? At what time it arrives here? So 16:10 plus. We have this is 16:10 hours plus 1 hour 45 minutes. So it arrived here at 17 hours. Then we have 55 minutes. So they arrived on Wednesday at 17:55 hours.